All right, we're good. Okay, all right, we're working. Okay, next one. The indefinite integral, sorry, we did do this. This is the one where you have to do the plus C, but there's just moving into some of the other types of things that we can find the indefinite integral of. So this should be a nice little one, familiar territory. So this is our first rule. If we're integrating our x to the power of n's, we add 1 to the power and we divide by that new power. But if we don't have any numbers on here, on our integral sign, we have to remember to add that plus c. Okay? Then there is these ones. If we are trying to integrate things that are in brackets that have a power. Now, the things that are in your bracket, it's a little bit different from when we differentiated. We had more things that we could do with that. When we integrate it, it does have to just be an ax plus b form, so like a 2x plus 1. We can't do the ones that have x squareds in here or x cubes in here, just a number in front of the x, okay? So when you integrate that, whatever the bracket is, boys, whatever the bracket is, you add 1, you keep the bracket the same, but you add 1 to the power. You divide by that power down here, but you also have to times by the number that is in front of the x, and then add your c. All right? So let's do some, starting with some easier ones and getting more complicated. So a 4, integrating 4. Because it is a constant, we're going to add an x to it when we integrate it, and then we just go plus c. Done. Next one, 18x to the 5. I'll do it the long way. It's 18x, add 1 to the power, divide by the power, plus c. So the 18 over 6 would be equal to 3x to the 6 plus c. And yes, you will lose marks if you forget the plus c. It is important. Question 2. Integrating brackets time. So the process was you keep the bracket exactly as it is. So there's my 2x plus 4. We add 1 to the power, which will become a 6. You divide by that power, 6 on the bottom, but you have to multiply that by whatever number is in front of your x in your bracket, which in this case is a 2. And you still have to add your c. So all you can do to tidy that up is just times those numbers together on the bottom. We have 2x plus 4 to the power of 6. All over 12 plus c. Okay, let's do it again. Part 2b, same process. So we keep the bracket the same. There's the bracket, but add 1 to the power, divide by the power, and multiply by the number in front of the x, which is -7. Good. Plus c. It's a 5 because that was the new power. All right, then that will make 3 minus 7x to the power of 5 over -35 plus c. Actually, to be even better, that minus sign, you could move out the front here. Question 3, what are we doing here? We're putting stuff on the bottom of fractions, which means we have to move them up before we can integrate them. So keep the integral sign there. The 9 is still a normal 9, but the x comes up to be an x to the power of -4. Okay, now I can integrate it. So keep the 9, add 1 to the power makes, very good, -3 over -3 plus c. 9 divided by -3 makes -3. Your answer should be in the same form as the question. So instead of putting x to the -3 here, I'm going to move that back to the bottom. So x over +3 on my denominator plus my c. Good job, Grace. Okay, B. Fractions and brackets, we can do this. First of all, change it to bring the denominator up. 3x minus 10 to the power of negative 2 dx. We'll sit that dx out the end there. Then keep the bracket the same. Adding 1 to the power makes negative 1. Divide by the negative 1 and times that by 3. Good, you guys have got this. Plus c. And to fix it, the whole bracket on the top has to move to the bottom. So I'm going to have just a 1 on the top. And it will be a 3x minus 10 to the power of 1. And the minus sign, I'm moving out the front, or you can move it to the top. Minus signs are really cool that they're so flexible and you can move them around. And that's it. All right, next page. Yeah. Oh, no, just the C. So the ones we were doing before had the numbers on the integral sign, so we were subbing stuff in afterwards. These ones are indefinite because we don't have those things. Okay, next page. Now, remember that I said that our rule for brackets only works if it's normal x's that are in here. Okay, you can try it if you want to. Try using the shortcut and try doing what I'm about to do and see if you get the same answer you want. So unfortunately, if there's an x to the power of 4 in there, I can't use that technique. So instead I have to expand it. The reason it doesn't work is because when you put that power on the bottom, you would have, 4x cubed potentially if you differentiate it at 4x cubed. And it's actually not 4x cubed that you need to go on the bottom of that fraction if you're going to try and use the formula. So I can show you that. I can show you that in a bit to see that it is different. But let me show you the correct way to do it. So to expand that out, I'm going to do the short method expansion here. X to the 4 times x to the 4 makes x to the 8. Then you have to double your middle. So x to the 4 times minus 1 is minus x to the 4, but doubled is minus 2x to the 4. And then minus 1 times minus 1 is a plus 1 dx. So I'm expanding that quadratic out using the short method of expanding. You can always put two brackets next to each other and do a full FOIL if you're worried. Okay, now I can integrate it. So add 1 to the power is a 9, divide by the 9. Then minus 2, add 1 to the power is a 5, divide by the 5. The 1, I need to add an x to that, and then a plus c. And that's how we have to do those ones. So I have the same problem with 4b because, well, there's two brackets for a start, which was never anywhere near that rule that I had. And I've also got these x squareds in there, which messes everything up anyway. So I had to expand that out before I integrate it. It is a difference of 2 squares. Both brackets are the same, except one's a plus in between, one's a minus. So it just means I have to do the first with the first and the last with the last. The two middle terms will cancel out. So it's 5 times 5 is 25. And then the last with the last, what's 1 over x squared times 1 over x squared? 1 over x to the 4. Is it positive or negative? Good. Negative 1 over x to the 4. Is that a good way to write it? What's a better way to write it? Because I have to integrate it. So we could do that straight away if that's not too much bending of the brain. Bring that up so that it's in a form that I can now integrate. All right, integrating the 25 will become 25x. Integrating x to the minus 4, we add 1 to become a minus 3 over minus 3 and the plus c on the end. Now those two minus signs will make a plus. So 25x plus the x to the minus 3 has to go to the bottom so that it has a positive power again. So it'll be 1 over 3x to the positive 3 plus c. So the hard part sometimes in these integrals has got nothing to do with integrating. It's the indices that you have to do or the expanding or whatever other things that go along with it. Question 5. Surds time. surds become fractional powers. Okay, so you always have to change them before you integrate them. So it's, okay, we've switched. We have numbers here. We've gone back to definite integrals as well. Okay, so keep that in mind. I'm integrating between 9 and 16, and I'm changing the square root of x to be x to the power of a half dx. Okay, when you integrate, you have to add 1 to the power. What's 1 plus a half? 3 over 2. Good. Improper fractions are best. Now, maybe don't write this down just yet. Oh, write that part down. The next part. Because what you want to do is you want to divide by 3 over 2, but that is yucky. I don't want to have fraction in a fraction. So if you are putting, guys, can you stop talking constantly? If you are dividing a fraction in a fraction, when you divide by fraction, you turn it into a times and turn the fraction upside down, right? Remember doing that in year 7, 8? Dividing fractions, turn it to a times, flip the last fraction upside down. So that means that I could times by, turn the 3 over 2 upside down to be a 2 over 3. Yes, we okay? Between 16 and 9. All right, then we are subbing numbers in. We have 2 times 16 to the power of 3 over 2 over 3. Then we are minusing, sub in the 9. So 2 times 9 to the power of 3 over 2 over 3. And then you can just type that in your calculator from there. So I just type in. We're going to practice. I got 74 over 3. Yeah, that's one yes. Good. All right. Few more questions to go. Part B. We have, look at our function, we have a surd, which is in a fraction. So it's going to have a fractional power and a negative in that power. Because the square root of x is the same as x to the half, and because it's on the bottom, it comes up to be x to the power of negative a half. Everyone okay with that? Good. All right, now we integrate it. We add 1 to the power. What do I get when I add 1 to negative a half? Half, a positive half. Then I'm going to divide by a half, but remember, flip that upside down, and what am I multiplying by? 2. 2 over 1, or just 2. So it is 2x to the half between 16 and 9. And then we sub in. So it's 2 times 16 to the half. Now, if you wanted to, because it's a half is a nice one. That's square root of 16 minus 2 times square root of 9. Those are both really nice surds. So square root of 16 is 4. So 2 times 4 is 8. And 2 times 3 is 6. So that whole thing is just equal to 2. Okay, next page. Question 6. Use index notation to express 1 over the square root of 7 minus 3x as a power of 7 minus 3x. They're setting it up. They're setting us up so that we can integrate it down here. So first of all, change the form. So if I do it in a couple of steps, since we've got all this space there for this question, that would be 1 over, put it in brackets, 7 minus 3x to the power of a half, because the square root is the same as the power of a half. I just have to put all that stuff in brackets to do that. Then I want to get rid of the fraction, so I can do that if I put a negative on that half. So it just comes up, 7 minus 3x to the power of negative a half. That's it for A. hence, when they say hence, it means use what you've just found to help you find this indefinite integral. So there is, it says a dx there, but if there's a dx there, it means there's a 1 in front of that. So it is a 1 over the square root of 7 minus 3x. That is this thing here. I don't want to integrate it when it's in surd form. That's too complicated. So we just use what we just found. I changed that to be 7 minus 3x to the power of a negative a half and slide that dx down to the end. Okay, so that's what I found in part A. So I've just changed my integral into that so that now I can integrate it. So this is back to the one that I do have a formula for. I just have a normal x in here. So I keep the bracket the same. I add 1 to the power, which will become a positive a half. I divide by a half, which is the same as timesing by 2. And actually, no, I won't do that though, because there's something else I have to do. I have to times the negative 3. So that's too messy to do in one hit. So let's do it in 2 steps instead. So let's put the half on the bottom, and then we have to times that by the negative 3. That made it a bit messier. And then I have to plus the c. So tidying that, 7 minus 3x to the positive a half. I'm just going to fix these numbers first. So half times negative 3 is negative 3 over 2. So now it's probably a good time to flip that upside down to be negative 2 here and 3 on the bottom. I am still not done because my question was in square root form. My answer must be in square root form. So that's the power of a half. It just changed back to a square root. So minus 2 square root 7 minus 3x all over 3 plus c. Or, I mean, you could even write that as a little negative 2/3 out the front if you want. It means the same thing. All right, 5e.